Namaste friends, this is Mandar Bhanushe from Institute of Distance and Open Learning, University of Mumbai. In this video lecture series, now we have reached the unit 2 of our section 1 of mathematics, and the title of this unit 2 is linear programming problems. In this video, we are going to discuss about what is a linear programming problem and how do you formulate a linear programming problem. So these are the two things which we are going to do in this video lecture. Let's begin. So this unit we are going to talk about linear programming problems, which is the second unit of our section 1 of mathematics and statistics paper of FYBCom. In our daily life, we all come across some specific target oriented situations. Like for example, we are students, and as a student we have to write assignments for every course. Now there is a deadline for every course, right? So if an assignment is given, then the assignment has to be submitted within a particular time frame. Also, when the student is aiming to submit the assignment, there is some target in the mind of the student, and the target is to achieve a certain amount of marks. So it can be to get as much as possible marks in that particular assignment. Similarly, let us have a situation where there is a company, there is an industry, and there are some products which are being produced here, manufactured. What would be the target of the manufacturer? The target would be to have as much as less as the cost of production, or the target can also be, in addition, it also can be to increase the revenue of the company. So these can be the two targets. And what can be the other things which are related to this? The other thing is there is a human resource, there is a machine, there are so many different things which are affiliated with that particular industry. Whether they are available or not available, for what amount of time, or the other parameters, that is also something which has to be taken care of. So this is a problem. And also we can take one more example. Let us take an example of a family which wants to do the renovation of their house. Now there are so many things associated with that. What is that do we want to renovate? So it can be a furniture, it can be fan, chairs, ceiling, and something else kind of thing. And doing all this renovation also has certain limitations, that say for example the total expenditure for the renovation should be a particular amount, it should not exceed that. So these are real life examples which we all face, and these are all situations which are target oriented. In a time frame they have to be finished with some kind of limitations. There are two things common in all these three examples which we have seen. So what is that? The first thing which is common is the objective. When a student is writing the assignment, as I said, what can be the objective of writing the assignment? The objective can be, for example, to get maximum marks. So this can be one of the objective. In the case of the company, what can be the objective? In case of company, the objective can be, as I said, to reduce the cost of production. And also it can be to have the maximum or whatever is possible, right? So just as we have maximum marks for the assignment, maximum revenue, this also can be one of the target. Similarly, in the last case, similarly in the third example, when the family would like to do the renovation, what would be their objective or what would be their target? Their objective can be to keep expenditure minimum. It can also be to have maximum things renovated. So that also can be one of the targets. Now this is one common thing in all these three examples. In addition to this, there is something else which is common. What is that? The other thing which is common, it is the limitations, or let us call them as constraints. So in the example of a student, what is the constraint? It is the time period of submission. So it can be, for example, 1 week. You have to submit the assignment in 1 week. In case of a company, what can be the constraints or what can be conditions? The constraints or conditions can be about the machines, okay, and the time associated to machine. Say for example, the power supply, it is there only for 8 hours, it is not more than 8 hours. So there is a constraint with respect to the running of the machine. The constraint can also be related to human resource. The human resource, the employees, the workers, they will not be able to work for a particular amount of time more than that. So again, there can be a constraint related to human resource. There can be constraint related to the wages. The company would not be able to give wages more than a particular money amount. And in the third example, where you have the household expenditure, what can be the constraints, limitations in this example? It can be the availability of, again, human resource. So for example, plumber, carpenter, anything else which you want to do, so it can be related to that. The conditions or the constraints can also be related to time, whether the family members are available at a particular time, at how many days they would like to do, they would like to finish in particular, say for example in 15 days they would like to finish the renovation. So these constraints, so what are the two things, as I said, common? Number one is objective, and number two is constraints. And this is a problem. So what is a linear programming problem? Linear programming problem constitutes of three different things. Okay. Number one, the objective of the problem. Number two, which is the constraints, okay, which we are actually going to convert into a mathematical equation. And number three, which is an assumption that obviously, if say for example, there's a company which is producing pens and pencils, then in order to reduce the cost of production or increase the revenue, some pens, at least you can say one pen, or at least no pen and no pencil. But of course, we cannot say in formulating the problem that we will produce -4 pens and -20 pencils. So negative values are not concerned. Therefore, the third component of a linear programming problem is called as the non-negativity condition. We'll understand this with simple examples as always. So what are the three parts when you are formulating a linear programming problem? The first part is the objective function. Generally, when we talk about an objective function, we write it as capital Z. Okay, so that is the way we always use. So we write this as, because everything is written in a mathematical format, so we write it using the alphabet Z. And generally the objective is either to maximize certain things, or the objective is to minimize. So when you are writing or when you are formulating the LPP, these are the two options. After the objective function, as I said, you have certain constraints, and these are all mathematical equations. So you can have equation 1, equation 2, depending upon the number of constraints, equation 3, and we'll understand what are these equations with simple examples as always, as I said. And the third part is the non-negativity condition. So for example, if you are producing pens, so the number of pens produced has to be greater than or equal to 0. You cannot have negative pens produced, right? If you are producing pencils, then it has to be obviously greater than or equal to 0. So this is just an idea about what is a linear programming problem. And now we shall see one very simple example and we will formulate the LPP for that particular problem. So here is the problem which has been taken from your study material. Let us read it carefully. It is very easy to formulate the LPP, which is a linear programming problem. Only condition is that you should read it carefully, write down the things in a very nice way in a table, and then you will get all the important things: the objective function, the constraints, and obviously the non-negative conditions are going to be there for every LPP. So the third component is easy, it is not at all difficult. Let us read the problem and understand. A manufacturer produces two types of toys. Okay, so now there is a manufacturer who is producing toys, and there are two types of toys for children. What are those two types? Flutes and drums, each of which must be processed through two machines. So now you can see there is this machine into picture. So there are two machines, machine A and machine B. So two types of toys and two machines through which these toys are made. And here starts the condition. You can read the maximum availability of machine A and machine B per day is 12 and 18 hours. So for machine A, how many number of hours is the constraint? It cannot work for more than 12 hours. So this is what we have to understand. The word is maximum. When you say the machine A can work maximum for 12 hours, means it can work for 11 hours, 10 hours, 9 hours, 2 hours, but cannot work for 12 plus some any amount of time. So 12.5 hours not possible, 13 hours not possible. So maximum time is 12, less than 12 is possible. Similarly, the machine B, it can work for maximum of 18 hours. The manufacturing of flutes requires 4 hours of machine A. So for manufacturing a flute, 4 hours of machine A is required and 3 hours of machine B is required. So flute can be manufactured by the combination of two machines. And what is the time required for manufacturing one flute? 4 hours for machine A and 3 hours for machine B. And for the case of drum, it requires 2 hours from machine A and 66 hours from machine B. If the profit is rupees 20 for flute and for drum it is rupees 50, formulate the problem to maximize the profit. Now this is a problem, and as I said that whenever you read the problem, you read it 2 times, 3 times and then write down the data which is given in the problem. That is the only way to solve the problem. And it is extremely easy, believe me, we'll do it in the next 2 minutes. So what do? We prepare a table. Now what is that which we require in the table? So there are two things which will take care. One is in the row we have to write down certain things and other is in the column. So we can write it the way we want, but let us use our common sense in writing down the row and the column headings. For example, there are two toys here. So let us take toys as the row entries and let us take the machines as the column entry. So how many machines are there? There is a machine A and there is a machine B. And how many toys are there? There are two toys. One is the flute, other is the drum. Right? Now you can see here that we have to formulate the problem, so we need to do some assumptions, right? We don't know what is, of course, we have been given the objective here. So what is the objective given to us? Is to maximize the profit. So we have to maximize certain things, right? So let me just write down the first thing which we have got from the question itself. Maximize something, okay, Z equal to, and we need to write down certain things here. We'll write it down. How many flutes and how many drums are to be manufactured? We don't know. Okay, so let us assume. Okay, so what do we assume? That we produce X number of flutes and we manufacture Y number of drums. Okay, so what do we do now? We go to this table and we write, suppose we want to manufacture X amount of flutes and Y number of drums. Now what is the condition, okay, which is given to us about the profit? The profit is that if you manufacture a flute and you sell it, you get 20 rupees of profit from one flute. So if there are X number of flutes, what is the total profit? 20X, right? If you manufacture one drum and sell it, you get 50 rupees of profit for one drum. So if you manufacture Y number of drums, what is the total profit for drums? 50Y. Say for example, you produce 2 drums, so 50 into 2, 100. If you produce 10 flutes, 20 into 10 is 200. So that is a simple mathematics. Now what is the total profit? The total profit is profit earned from flute plus the profit earned from drums, correct? And now this becomes your objective function. So this is your objective. What is your objective? To maximize Z equal to 20X plus 50Y. From where is this coming from? This mathematical equation is coming from the last statement of the problem, which talks about profit earned per flute per drum. We assume the number of flutes to be X and number of drums to be Y. So 20 into x plus 50 into y, this is a total profit which we want to maximize. So first part of the objective function is done. Now there is a constraint. There are two types of constraints given in the problem. Let us again go back to the problem and read. The maximum availability of machine A and machine B is 12 and 18. Now if you want to produce a flute, how many number of hours is required for a flute of machine A? 4 hours. And how many number of hours required from the machine B? 3 hours. Right? In case of drums, what is given? In case of drums, it is given that to manufacture a drum, you require 2 hours of machine A. And how many hours from machine B? 6 hours from machine B. 6 from machine B. Okay. And what is the constraint which we have about the machines? How much time they are available? So machine A and machine B can work for 12 and 18 hours only. Okay, so the total hours machine A can work is 12 total hours. So 12 hours is the maximum for A and 18 hours is the maximum for B. Now once we have this table prepared, we have to formulate the mathematical inequation for the two constraints. So what is that for two equations which we have? See, machine A maximum can work for 12 hours. It can work for less than 12 hours? Yes. If X number of flutes are manufactured, the total hours on machine A will be 4 multiplied with X. And if Y number of drums are produced, 2 hours of machine A is required. Total number of hours for machine A for drums is 2Y. And this 4x plus 2y is what? The total number of hours to manufacture flutes and drums through machine A. That constraint is maximum 12. So it can be less than or equal to 12. This is your first constraint. In the second constraint, same way, for manufacturing X number of flutes, machine B, how many hours are required? 3 hours are required. So what is the total? So what is the total number of hours required for machine B to manufacture flute part? 3x, drum part 6y, and flute plus drum machine B, how much time? 3x plus 6y. But machine B cannot work for more than 18 hours. It can work for any number of hours which is less than or equal to 18. So this becomes your constraints. So this is constraints. Okay. So this is your first constraint, this is your second constraint. And the third non-negativity condition, we know that of course we have to produce at least nothing, 0 flute and 0 drums. That is a minimum thing, but of course nothing can be negative. Let us see this, what we have written in the table. Let us put it in the equation format now. So what is a linear programming problem now? The linear programming problem is maximize z equal to 20x plus 5y subject to the first constraint, which was 4x plus 2y less than equal to 12, 3x plus 6y less than equal to 18, and the non-negativity conditions x greater than equal to 0, y greater than equal to 0. This is the formulation of the LPP. So when you are doing the problems which is given in the study material also, think it in this way. Let us do one more problem and then we will be able to understand it better. So this is another problem. Now the only difference between the second problem and the first problem is we have added one more parameter to that, one more variable to that. Okay, I have deliberately kept it in 3 different fonts so that you can understand it better, you can differentiate it better. Let us read the problem. 3 different kinds of food, A, B and C. So there are 3 different types of foods here, A, B and C, and they are to be considered to form a weekly diet. So there's a dietitian who has given this task to the person, and there is a requirement, minimum weekly requirement of 3 components: fats, carbohydrates, proteins. And what is a minimum requirement in the diet? Minimum, okay, please remember this word, this is very important, minimum diet requirement. So minimum, you can have more than that. So minimum 12 fats, 12 units of fats, 30 units of carbohydrates and 20 units of proteins is the minimum. So can you have, instead of 12, can you have 13 units of fats? Yes, minimum. Okay, usse zyada chalega. 1 kg of food A. So if you take food A, say for example you take salad for example, or you take some kind of sabji. Okay, you can think of this A, B, C in that format. So 1 kg of food A has 2, 16 and 4 units respectively of these ingredients. What are those ingredients? Fats, carbohydrates and proteins. Similarly, 1 kg of food B has 6, 4 and 3 units of fats, carbohydrates and proteins, whereas 1 kg of food C has 1, 5 and 7 kgs of these ingredients, right? If the cost, now here the word is cost, whenever the word cost comes, obviously the problem will be to maximize or minimize. Would you like to increase your cost or decrease your cost? Obviously decrease. So the objective here will be to minimize the cost. What is given? Cost per kg of food A is 75 per kg, for food B it is 80 rupees per kg and for food C it is 60 rupees per kg. Construct the problem to minimize the cost. So this is a problem to minimize the cost. Let us write down. So what is that we want to do? We want to minimize, and let us write down Z as your cost function. So we want to minimize. Now we want to again put it into some kind of variables, right? So let us say X, Y, Z stands for food A. What, how many kgs of food A? Okay, so X kgs of food A and Y kgs of food B and Z kgs of food C is being considered. So let us write down, so let us say this is the food here and we have A, B and C, and then we have again three types here, right? So what is the requirement? So you have requirement of fats, carbohydrates and proteins, right? So let us say X kgs of food A, Y kgs of food B and Z kgs of food C is what we are considering. Now the constraints are given. What is the constraint? The minimum weekly requirements of fats, proteins and carbohydrates is 12, 13, 12, 30 and 20 respectively. Let us take the example. Let us fill the columns and the row entries which are there in the center. So 1 kg of food A has, as it is given here, 1 kg of food A has 2, 16 and 4 units of these ingredients. So 2, 16 and 4. In case of food B, it is given as 6, 4 and 3. So we have 6, 4 and 3. And in case of C, it is given as 1, 5 and 7. So we have 1, 5 and 7. Now, what is the constraint? That the minimum requirement of fats is how much? Okay. So, minimum requirement. What is the minimum requirement of fat? In case of fats, it is 12. In case of carbohydrates, it is 30. And in case of proteins, it is 20. Okay. And the profit for A is 75 per kg. So, for 1 kg, the profit is 75. How many kgs we are assuming? X. So the profit for A was not the profit, sorry, the cost. The cost for A is 75x. For food B, it is 80 rupees per kg. So we are taking Y kgs. So 80 into Y, and 60 rupees is for C. We are assuming Z kgs. So 60 into Z. And this is the total cost for 1 kg. So this is what is the cost, 75x plus 80y plus 60z, and this we would like to minimize. This is our objective function. And now we know that this is easy to put into a mathematical inequation. So for example, x kgs of food A is to be considered. Minimum fat required is 2 per kg. So the total fat for A will be 2x. For B, it will be 6 into Y, 6Y. And for C, it would be 1 into Z, which is Z. So what is the inequation which we get? We get, I can just write it down, 2x plus 6y plus z, and this is minimum. So more than that is possible, so greater than or equal to 12, right? And similarly for the second one, it is 16 into x plus 4 into y plus 5 into z. We just add these two. Minimum is 30, greater than 30 is possible. For proteins, it is 4x plus 3y plus 7z greater than or equal to 20. Now, when I combine all these three things in the equation, we get the linear programming problem formulated as minimize z equal to 75x plus 80y plus 60z. First constraint 2x plus 6y plus z greater than or equal to 12, 16x plus 4y plus 5z greater than or equal to 30, and 4x plus 3y plus 7z greater than or equal to 20. Obviously, the non-negativity conditions are going to be there: x greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0. So these are the two examples which we have discussed, and in this similar manner you can formulate the LPP by considering the objective function, by making the table and then writing down the inequations. These are the constraints. The third part is the non-negativity conditions. And now we are to the end of this video lecture. It is a time for you to practice what you have watched in this video. In the description box, we have given you a problem to formulate the linear programming problem given the conditions and given the constraints in that particular problem. Do solve it and share the answer or the solution in the comment box. We would be happy to read your comments and also feedback suggestions. I hope you have liked the video, so press the like button and also do subscribe our videos. In the next video lecture, we will see how we solve the linear programming problem. What we have seen now is formulation of a problem. Then we will see how to solve the linear programming problem. That is in the next lecture. Till then, thank you for watching. Namaste.